You can, and then you have the nonmetals too. Now, oftentimes for the covalent bonds, they have metalloids that are included with those as well. So it could be metalloids and nonmetals as well. So something like silicon added together with oxygen. That's also known as sand. Yeah.
This is in the quest, the last section.
Oh yeah.
I want to go over the properties.
The properties of those?
I just like.
Let's do that right now.
I did not get that.
What are bonds? Properties of bonds.
Oh, is that gonna be on there?
Yeah.
Oh my god, I got all that wrong.
Yeah, exactly.
Yeah, I forgot to.
I think I did a good point by pointing out on that one.
Okay, let's talk about this really quickly. So we've got metals,
It is proper.
properties of bonds.
In
Yeah.
I
ionic
got
bonds,
every single one of those wrong.
Yeah.
Not once did I get it
What were you going to say to this? In covalent.
in
right.
ionic-
I really didn't get it.
Okay, now what's important with these is the basics. You don't need to memorize a whole bunch of stuff here, just how these bonds are put together. And that will tell you everything else. Okay? So for instance, metals, they're put together by having a bunch of atoms kind of like sharing their electrons. They're in a sea of electrons, they're floating all around them, holding them in place. Okay? If you know that, then you'll know, like I'll just draw a little diagram right here. This diagram's in your notes, I'm sure. But you've got all the nuclei, the positive nuclei, the nuclei.
C of electrons.
Yeah, so here are all the little electrons kind of floating around, also holding all of the positive nuclei in place. So they're kind of like, remember we said like plum pudding before? It's kind of like plum pudding, except for now we've got, are you alright?
Yeah.
Okay, we've got these, you're trying to fit your hand closer to the table.
Gecko.
Like a gecko. Yeah. So you got all these electrons that are floating around here. That tells you a lot of properties right away. That tells you that electricity can easily pass through here because electricity is just flowing electrons, right? It also tells you that heat can be conducted really easily too, because heat is just movement of atoms, and this could be movement of electrons as well. So you can have this kinds of like really, really, really easy to conduct heat if you have these loose assortment of atoms. So that's why you don't touch the handle right next to the, or like the metal handle of the hot stove, right? It's not a smart thing to do. It also conducts, oh, we already said conducted electricity. It doesn't dissolve very well in water because they're already embedded in this big kind of matrix of electrons.
So it conducts electricity, doesn't dissolve in water.
It's also got a very high melting point.
High melting point.
High melting point. High.
It doesn't
I put all the
And it doesn't
ones
dissolve in
for
water, that's right.
ionic, all the ones for ionic and covalent, and
When you
ionic,
think
just
of
mixed up
ionic,
the
you think
time.
of salt. When you think of covalent,
There you go. Very good. Think of-
Covalent sugar.
yeah, when you think, because remember the salt, when you did that experiment, the salt didn't melt, but the sugar
Yeah, there you go. Use your experience. That's good. So we had a little experiment where we made caramel basically.
Oh
Caramel,
yeah,
or however
Why
you want
did
to
we
say it.
get to do
caramel.
We did. Caramel.
Caramel, back in Nebraska.
Back in Nebraska. Caramel. Right. Here's the ionic bonds. It's killing you. Here are the ionic bonds. They're held like this, right? Because you've got this very negative ion, you've got a positive ion, and that's how they're attracted. They're in this big lattice. Remember the lattice?
Oh,
That
I thought
lattice.
lattice was for metal.
That's what I got.
Lattice probably means something in French, doesn't it?
Yeah, it does, but I don't know what it is.
Okay, cool.
I really don't.
Because it's Spanish.
But that's the Spanish side. Maybe you'll know what that means. Anyway, so
Oh, okay.
that's the ionic lattice right there. So that tells you a lot of properties about it. For one thing, it doesn't conduct electricity because the electrons are kind of stuck in that place. But it does get dissolved in water really well. Water just comes along because water is, now we know water is that kind of polar molecule. It acts like a little magnet, and it can kind of take apart piece by piece every little bit of this magnet.
Doesn't it also have a high melting point?
This has a high melting point too. All the things are locked in place. It's also very brittle. Brittle, but I mean it cracks very easily. If you apply like this force right here, I don't know if we went through this all that much, but if you apply a force, a very direct force in between here, you can break them apart. Just like you can break apart a magnet pretty easily if you go hi-ya.
Not the magnets that Mr. Greg has.
Okay,
No.
so ionic, they also dissolve in water, right?
They dissolve in water, yeah. What else do we need to talk about?
Can they conduct water?
They conduct electricity in water. You did a whole experiment about this. Remember this?
Yeah.
The light bulbs? This is like, oh my god, so long ago.
They don't conduct electricity outside of water, but in water they do.
That's right.
That's very confusing.
Well, does that make sense though?
Yeah.
And you guys know how that, well, it's not all that important that you know how that electricity gets carried through the water.
Yeah.
You could maybe puzzle that out. Yeah.
What's the structure have to do with like it dissolving and the high melting point? You said something about the structure.
Yeah, the structure for this, the reason it's got a high melting point is because these are kind of locked in place
Okay.
right here. It's difficult, even if you put a lot of heat to this, it's going to resist it. Because these things aren't moving around that much.
Okay.
And here, it's a little bit different reason. The heat, it conducts the
It
heat.
goes through the passes just like.
Right, but these are still kind of, these electrons, even though they're moving very fast and the whole thing really gets hot, it still doesn't melt because they're still pretty stable
Okay.
staying right there. But this is all different for covalent bonds and things like sugar.
Low melting point.
Right, because here we've got a low melting point. It doesn't conduct electricity. It doesn't conduct heat. In fact, everything that you see that's an insulator, remember insulators? That's a word that we didn't know.
No.
A lot of people didn't know that before the
Unless
quiz.
it's dissolved in water.
Was it?
Sorry.
Covalent bonds?
Oh, I thought it was.
We're now on covalent. So covalent,
Okay, cool.
think about them. You've got this, let's see, positive, and they're sharing their electrons.
That's cute.
Because sharing is caring.
Exactly.
Sharing is caring? Or, I don't know. So anyway,
Oh, it's like a Venn diagram.
it's like that. They're holding their electrons together. They're like holding hands. They're holding
Aw.
atomic
This
hands.
is definitely Barney.
Yeah. So there's covalent bonds. And these things, they melt really easily. They melt easily.
Oh, so it's covalent shares and ionic transfers, right? Electron transfers,
Transfers, what do you mean?
like transfers of electrons.
Yes, that's right.
Ionic.
Ionic transfers. They shoot out the electron. Remember that harpoon mechanism where they shoot it out and they reel it back in? Everything okay? Good.
Oh,
What else do you need to know about this? Oh yeah, it's always an insulator. So every glove that you use to handle like a, I don't know, a hot pan or something like that, it's made out of cotton or like some thick plastic soft thing that allows you not to feel any of the heat. That thick plastic soft thing is made out of covalent bonds. It's not metallic bonds. It's not ionic bonds. It's
So-
covalent bonds.
It does or does not conduct?
It does not.
But it's because
Doesn't conduct.
You right, Gabe?
yeah, I got number 12.
Yikes.
What? You have one 11:30.
11:30, sorry.
I got one at 12.
You got number 12. I got 11:30.
Way to go, Nino. You win.
Yes.
All right.
Probably not a
Next.
good thing to tell a teacher.
Boom, boom, boom.
Wait.
Let's talk about-
No, you took one too much.
No, I took off properties and I thought types of bonds already.
You
Just
wrote one more thing you like squished in. No, it
That
was
was-
just parentheses.
Wait, you did types of bonds?
Yeah.
already?
Relax.
Let's do polyatomic ions. Let's name them first. You do that sort of stuff because this is kind of like what we talked about. You get the chart for that one.
Wait, so on the test, would you possibly put a chart?
Like this?
Yeah.
Wait, let me show
No,
this to the
like-
camera.
No.
This thing right here, you will get
No.
what? That?
Yeah, like that.
No, because you've already done that.
That's what we just did.
No, I'm saying on the test.
No, I can guarantee you won't have that on the test.
Oh,
But it'll be silly. Like,
It
you
won't-
have to know it. You have to know
What?
I can tell you what right now. It's going to be a question you'll need to know about the different
The
kinds of properties.
Okay.
It's a short answer. It's a short response.
Like the one like
Not an essay,
the
but
ground thing on the class.
yeah, kind of like that. Except this one, actually, I think this is the test people have the most fun with. Yeah. Nino's gone away.
Keep that one.
Okay, let's do this. We got a metal, and we've got a
Wait, what is this?
We're gonna do polyatomic ions.
Oh,
We got a metal, and we have a polyatomic ion, which acts like a non-metal, I
atomic.
guess.
It acts as a non-metal.
Na2H2PO4. Okay.
Hydrogen.
The first thing you do when you look at this is you don't panic, but you should think, wow, that's a big, big chunk of stuff. That big chunk of stuff is probably a polyatomic ion. So then you should look through your chart and say, oh my god, that big chunk of stuff is a polyatomic ion, and I can find where it is. I see it's the very first one.
Dihydrogen phosphate.
Yes, dihydrogen phosphate, and that has a -1 charge. So that -1 charge for the dihydrogen phosphate means that this whole thing, this whole big chunk of stuff, this takes, or you could say needs, since we've been doing that, we can always say it, this one needs how many electrons?
One.
One, yeah. It needs one, and this sodium over here
Gives one.
gives one. Oh my god, it's like already balanced. Let's just keep this consistent though. Gives one. I kind of.
So it's
So this one is just going to be Na1, H2PO4, 1. And you know, this is not a transition metal, so we wouldn't have had to do anything differently anyway.
so it's
We
sodium
don't have to like
dihydrogen
write the one,
phosphate.
no, right?
So now what the name is,
You don't have to write a one and one.
no you don't, because it's not a transition metal. But I just did that just to make sure that's all. Okay,
So
so this is going to be sodium.
dihydrogen phosphate.
Yes.
Oh, okay. Just really quickly.
Yeah.
When do you use like the di-mono?
That's covalent bonds.
Okay.
Do you want to talk about that or no?
I mean,
It's pretty simple.
pretty simple.
Yeah.
No, I was just asking like ionic ions.
Okay, let's make this more difficult. Let's take this away and let's put a transition metal in. Here, this is where people go cross-eyed. Alright?
Whoa.
I just,
Are you sure you want me to do this?
that's all I did right there. I just put an Fe, that's an iron. That is a transition metal. I'm going to keep the dihydrogen phosphate at the end.
Like do one.
Haha! Iron, and then I'm going to leave a little blank right here. Okay, so
Iron one.
in this case, we don't know how many iron's giving. We needed to figure out how many iron is giving. Well, we know that this dihydrogen phosphate needs one, so this must
Give one.
give one. Yeah, it gives one. Gives one. So let's put a one right there.
That makes so much sense.
Yeah, that's
Good. Let's make it a little bit more complicated now.
No.
Of course. Let's make it now phosphate.
I thought it was phosphate.
Keep the iron.
That's dihydrogen phosphate. Now let's just do
Oh, it's
Fe.
just phosphate?
PO4. This still is a chunk. I'm going to move this over here just a little bit so you can see. FePO4. So now it's phosphate just over here.
So what's it?
So,
Negative three charge.
So I
Number
need
six.
three, and iron gives three.
right, so you looked it up in your chart and you saw that it needs 3. And iron needs to give how many?
Three.
3. It gives 3. So this is going to be iron 3 phosphate.
We're gonna get it.
Oh, but now we can make it even more difficult. Are you ready for this? I don't think you're ready. Here it is.
You're ready.
I am so confident in my inability to do well that I will bet on
Wait, what?
Let's say that this is now 3.
it.
Whoa!
That means it needs
Nine.
12 of them, which means you keep
Nine.
them 12.